Hello everyone, welcome back. We looked at the tech-free short response paper in the previous video. We're going to tackle the multiple choice today because that really completes sort of the entire first paper. I don't have a current calculator, so we'll see how we go with the tech active. I can kind of find workarounds, but I really want to show and demonstrate how we use the technology well. So maybe I'll see if I can find a way to get one of my old calculators back. But for now, we're going to be looking at the tech-free, the multiple choice questions. It's kind of weird, like, you know, when we did the short response, I covered 9 questions in the short response from question 11 to question 19. So even though it's going to be a bit of a shorter video, I'm going to cover 10 different concepts throughout solving these questions. So if you're looking for a bunch of general ideas and how hard the multiple choice section is and some strategies around multiple choice, then this is definitely the right video for you, because we're going to cover some more stats. There's no real statistics at all in the tech-free short response section. All the questions were essentially some combination of complex numbers, vectors, calculus. I feel like I'm missing one. Proof by induction. There was some differential equations as well, which is part of that calculus bubble. So we're going to cover a little bit of statistics with the multiple choice, because there's always going to be some stats questions in the multiple choice in the tech-free paper. So we'll cover more topics throughout this one. So hopefully this will be very informative. And again, if you're looking for multiple choice strategies, then I can talk a little bit about some tips and tricks for multiple choice as well. Let's get into it. So, question 1. Which of the following is a population parameter? So we have a statistics question off the bat. This stats question specifically is testing, these are all symbol familiar, the multiple choice. I heard that's going to be maybe adjusted at some point, but for now, all the multiple choice questions are simply just simple familiar. So simple familiar questions are normally testing one skill, or sometimes it can be 2 very small skills. This is just straight up, did you read the textbook intro to statistics properly to identify the difference between population versus population parameters versus sample parameters. That's really all this is getting at. So, this is really our sample standard deviation. Sometimes it's called standard error or sample standard error. There's a few different words for what this S term means, but overall, not a population. This refers to a sample. U is the sample mean. So that looks like my right answer is going to be part B, right? U is the sample mean. Oh, sorry, not the sample mean. Sorry, U is the population mean. So it's a population parameter. That should be the right answer, but just to make sure, X bar is the sample mean. So it's not going to be that. So we can rule out A, we can rule out C. And then D is a complex number Z. Normally we use Z for complex numbers. It's not going to be that either. So it made sense to pick B when we saw it, but we are just making sure, again, in an exam, it's a time-based assessment. Normally the way it works is you have about 1.5 minutes per multiple choice question. We came well under that time, so we're A-okay to spend those extra 30 seconds making sure that that is the only viable option. We come down to question 2. When the polynomial P of Z equals z cubed minus I z squared minus z minus I is divided by z minus I, the remainder is. So we have a factor remainder theorem idea, really remainder theorem specifically for this part. If I know, or I should know, I can find the remainder, right? Normally the theory states that this is the idea of like z minus alpha, where if I sub alpha into my polynomial, I will wind up with the solution. So in this case, alpha is going to be I. I simply just find P of I substitute in I, and I should get my answer. So if I do that, I get I cubed. I'm going to zoom in slightly so I can hopefully write a little bit neater. I get I cubed minus I times I squared. Very nice. Minus I minus I. So what I wind up with is I cubed minus 2i, because I minus I gives me negative 2 lots of I. And I can hopefully see that I cubed minus I cubed is going to disappear and become 0. I'm simply just left with negative 2i. So negative 2i, or A, is going to be the correct answer for question 2. So just remainder theorem to find my remainder. I basically let this part here, hang on, let me erase this. To make this make sense, I basically let this equal 0, and then I rearrange, okay? I let it equal 0, I rearrange. We have more terms here, right? So we rearrange. Whatever winds up here on my right-hand side, that is what I substitute into my polynomial to find the remainder. Okay, I'm going to erase this, just so we can see question 3 nice and clearly on the screen here. I'm going to zoom out, make sure that my head isn't covering the answers. Well, this is awkward. My face is in the wrong spot. So watch this. I'm going to teleport. Okay, hang on. Whoa. Look at that. Bam. Probably better for the multiple choice paper for me to be on the other, on the other side. So, now that I'm on the other side, we can see my questions nice and clearly. I'm going to zoom in a little bit more. I'll just try not to write behind my own head. An object has a velocity vt equal to e to the negative 2ti plus 1 over tk, where t represents time. Great. The displacement rt of an object could be. So really, we're trying to find the displacement. I simply just need to integrate my velocity. Very nice for question 3. I'm going to integrate my velocity equation. If I integrate my velocity, if I integrate v of t with respect to t, I'm going to wind up with, well, if I integrate e to the negative 2t, I simply just divide by the bit that's in the power. If I do that, I'm going to wind up with negative 1 over 2 e to the negative 2ti. And hopefully we should be able to differentiate 1 over t, right? It's like t to the negative 1, raise the power, it goes to 0. Oh no, problem. It's going to be a natural log. So I'm going to wind up with plus the natural log of tk. And look, I guess I should consider, right? I'm integrating. Plus c exists here, and I can consider my plus c. However, it says the displacement of the object could be. It's not saying it definitely is saying which one of these makes the most sense. None of these questions have a part C. None of these questions, or like a plus C on them, I should say, and none of these questions really give us any indication. There's no initial conditions. There's no way for me to find C. So I can consider it, and I'm considering it irrelevant. That's basically the consideration. So if I look at my solutions, well, I can rule out A and B immediately. Okay, one, they don't have the negative half out the front, so that's just gone. And oh my god, my words just never came out of my mouth then. Integrating an exponential is a skill that we get in methods, right? It should be relatively well trained, and it should be something we can see pretty instantly without having to necessarily write it down. If we're not at that point, it's fine, but for some of us, we've got to look at that question and immediately go, okay, well, A and B is not going to be it. I'm down to 2 options. If we look at 1 over t, we should also recognize that's a natural log. So this would be an example. I spoke about strategies at the beginning. This would be an example of a question where you didn't need to actually write out anything here. Obviously, if you have time and you're worried, you just want to make sure you get the answer right, you are welcome to do that. However, it's not necessary for this question. You could look at the first part, the exponential, integrate that and go, okay, well, that rules out the first 2. And then 1 over t has to be the natural log. It can't be 1 over t squared. So it's not going to be D. The answer has to be C in this case. Because again, like I said, we could process of elimination, get to our answer without actually having to go ahead and do the full integral. And we can save ourselves a little bit of time that way. If we come down to question 4, or I should say, we go over the page to question 4. I have a lot more words. The number of sunflower seeds in each packet produced by a company is known to be normally distributed with a standard deviation of 100. Fine. A worker counts the number of seeds in a random sample of 4 packets. Okay, so this is pretty important, right? I got 4 things in a sample. And I calculate the sample mean. Okay, I'm going to calculate the sample mean. Based on this sampling, the standard deviation of the distribution of the sample mean is, wow, a lot of ofs there. Double ofs. So, like, this is one of the questions where having a little bit more time is really useful because it's going to be relatively straightforward. Just really easy to make an error. We should know a few things. It says the sample mean's calculated and then proceeds to mean you don't have to calculate the sample mean. So I highlighted that thinking, oh, I'm calculating the sample mean. That was incorrect. I'm not... Why? Hey, hang on. My pen's not working. There we go. Whoa, standard eraser. Thank you. I'm not calculating the sample mean at all. I'm simply actually finding the standard deviation. I'm actually finding the standard deviation of the sample. Basically, that's what it's saying. Okay? So I know that the normal distribution, the standard deviation is going to be 100. So this really is using this formula here from the formula sheet where I say my sample standard deviation is equal to the population standard deviation divided by the square root of n, where n is the number of things in your sample. I know my population standard deviation is going to be 100. The number of things in my sample is going to be 4. So I simply wind up with 100 divided by 2. That equals 50. So my answer is going to be B. Okay, and this is one way you could write them out. At this step here, you could realize the answer is going to be 50 and you could circle your bubble straight away. If you save a little bit of time on multiple choice, it does give you more time to spend on the complex, unfamiliar questions. Okay, I said it's about 1.5 minutes per question in multiple choice, which really gives you 15 minutes to complete the whole section. Now, I might not do it in 15 minutes in this video because I'm explaining each step and I'm making sure we all understand all the principles behind what's happening. But you should be able to, by the time we get to the external exam time, hopefully, finish the multiple choice section within 15 minutes. And I'll talk about that a little bit more at the end. So we come down here to question 5. Again, I'm going to get rid of this part here. If we come down here to question 5, I'm going to have to zoom out a bunch. I'm going to zoom in a little bit. Okay, here we go. So, I've got a geometric interpretation. The augmented matrix shown is produced when a Gaussian elimination technique is used to solve a certain system of equations with 3 variables. Okay, the geometric interpretation of this solution to this system of equations is best represented by. Okay, so we really need to look at our final line. All our information really comes from the final line here. Now, what I can see is that I have 0, 0, 1, 0. That means if I translate this to something a bit more tangible, okay, that means I have one lot of z is equal to 0, so therefore z equals 0 if I divide both sides by 1. So what happens, essentially what this means is I have a clear answer for a point of intersection of 0 for my z coordinate. I could then substitute that in here, and I get negative y. Well, it's going to be plus 5z equal to negative 6. I know z equals 0, so I essentially wind up with y equals 6, and I've got a z coordinate. I've got a y coordinate. I do the same thing. I get an x coordinate. So if you recognize in that bottom line that I'm going to get a unique solution for z, we can pretty easily see that we are going to get a unique solution overall. Okay, so this particular system shows a unique solution. Your other options are no solution. That would be like something in B where none of the planes intersect. You could have infinite solutions. That would be something like in part A where they intersect in a line. That is not what's being represented here. What's being represented here by this system is a unique solution. And you can see I kind of demonstrated why it's a unique solution above, which means I need to pick the system that is going to give me a unique solution. Well, I just ruled out the first two. You can see this is all in one straight line. This straight line technically goes on forever. Infinite solutions. There's no solutions here in part C. So it's going to be D. This is the standard picture for what unique solutions look like. If you've never seen it before, this is what unique solutions look like. They all basically touch just at this little dot here in the middle. Okay, you can see all 3 planes only intersect at that one specific point. So that is why it's going to be D for my answer. Alright, question 6. Complex numbers. Oh my god, I nearly dropped my water bottle. For question 6, complex numbers, the subset of the complex plane that represents the modulus of z equal to the modulus of z minus 2 for z is some complex number. Yeah, we kind of gathered that is going to be given by the following diagrams. We are picking what is the best subset for this plane, and it's nothing too crazy. We've got a bunch of linear relationships, right? So it's horizontal or vertical straight lines. They're my options. So normally when we do questions like this, the way I recommend approaching the solution part, especially for short response questions, is simply just let z equal x plus yi, and I prefer using the letters x and y for one main reason. It looks more similar to a Cartesian plane, and it's easier to identify what type of equation I'm dealing with. So if I do that, I can put it in both spots. If I put it in both spots, and we can do a little bit of this without doing a bunch of working out, but I'm just going to do the working out just to show where we get our answer in case we get something more complicated than this, is I have the modulus of z plus yi, my only option, equal to the modulus of x plus yi minus 2. Now, you can see I'm finding the modulus of both sides. There's a few little tricks I could do early on to get rid of this, okay? Before I do that though, I'm going to start by collecting my real and imaginary parts on the right hand side. So the left hand side is going to stay the same. The right hand side is going to give me the real parts are x minus 2, and my imaginary part is still going to be plus yi. Now, I can actually square both sides here. As long as I balance, I'm fine. If I square this side, and I square this side here, if I square both of my modulo, and I can take them out to square roots first, right? But one of our complex number principles is if I square the modulus of a complex number, I get the real part squared plus the imaginary part squared. I explained that in a little bit more detail in the short response video, so feel free to watch that on the complex numbers proofs. I think it's like question 13 or something. You can watch that for a little bit more explanation if you need it. However, assuming we are somewhat good with that idea, if I square the modulus of a complex number, I get the real part squared plus the imaginary part squared, and I'm going to do the same thing on the right hand side. My real part is x minus 2, so I'm going to square my real part, and I'm also going to square my imaginary number y as well. And again, the I is going to disappear, because the i's always disappear when we do this. Again, the modulus, I'll explain a little bit. The modulus is the square root of my real part squared plus my imaginary part squared if we just do this for this side here, right? That would be what my modulus gives me. If I square that, square root disappears, I'm left with just x squared plus y squared. That's basically the explanation for why it works. So once I do that, I can expand the brackets. I'm going to erase this little part here at the top, and I'm going to grab everything, make it slightly I'm just going to pull it up actually. I'll pull it up so I have a little bit more space to finish off my problem. So my x squared, y squared part's going to stay the same. If I expand this side, I get x squared, multiply them together and double it, or double the product, however you want to expand your perfect squares. You do FOIL, do it the long way, that's fine. However way you do it, you're going to wind up with minus 4x. And I'm going to square my last term, that's going to give, 2 squared is not 2 squared is 4. And my plus y squared is going to stay there as well. If I now go ahead and... Well, I was going to say collect like terms. Really, I can actually just cancel these out, right? I can subtract x squared and I can subtract y squared from each side. It's now gone, and I'm simply left with 0 is equal to minus 4x plus 4. I can subtract 4 off each side. I'm going to wind up with minus 4 equals minus 4x. Oh, that's behind my head. Apologies. I can now divide both sides by negative 4, and I wind up with x equals positive 1. So I've done a lot of work. I could actually get my equation. I could see where my equation is going this slightly earlier on. If you can identify that, that's great, because you can save yourself 10 seconds-ish, right? But again, you only have a minute 30, so that 10 seconds can matter. So we got this x equals 1. I look at my graphs. Well, you can see it's halfway, with this one here, it is halfway between 0 and 2. So this here is going to be the equation. That's the wrong pen. This is going to be the equation of x is equal to 1. This is x equals minus 1. So if you make a small mistake or you're not sure which one to pick, right, that's why it can be worth going all the way to make sure you get the right solution, because the correct answer should be C. And again, A and B, they're horizontal lines. That would be y equals 1 or y equals minus 1, but all the y's disappeared, so it's going to be just, well, it's x equals 1, and I think we hopefully all understand where that solution came from. Well, hopefully I'm making sense. I mean, that would be good. So we come down here to question 7. In question 7, the mass of a particular variety of cake okay, is claimed to be normally distributed with a mean of 660 grams. A random sample of 5 of these cakes is found to have a mean mass of 600 grams. Which option best represents an approximate confidence interval for you based on this sample? Okay, so the sample mean of 600 has to be in the middle of my confidence interval. My confidence interval formula, if you guys remember, is essentially, it is like, you know, it's x bar plus or minus your z score, and then it's just standard deviation over square root n. There we go. There's our confidence interval formula. So the sample mean, x bar, has to be in the center of the confidence interval, which means I can immediately rule out A, because there's the sample mean. It's nowhere near. I can immediately rule out C, because there's the sample mean. It's nowhere near. And I can immediately rule out D, because there's the sample mean, and it's nowhere near. So I don't need to do too much work with this to realize that, okay, my sample mean needs to be in the center. My only option is going to be B, because it's literally the only option with the sample mean in the middle of the confidence interval. Now, where it's trying to get you is that you know the actual mean should be 660 grams. So shouldn't the confidence interval include the population mean? And it should, but let's say it's an 80%, we don't know the confidence interval percentage. Let's say it's an 80% confidence interval. That means 20% of the time, the mean's not going to be within the boundaries. So it's perfectly acceptable to get an answer where the population mean is not actually within the confidence interval, because it is a probability, essentially. It's a percentage. It's a I guess at 80% of the time, we think this is going to contain it. In this case, it obviously doesn't, but they're trying to kind of confuse you a little bit with, oh, should we consider this 660? The answer is we don't really care at all about the 660. We just care about the 600 in this particular question. We also know the sample's only got 5 things in it, so it's going to be not the most accurate. So it also kind of supports the idea that B is a very, very likely solution. Oh, that's the end of the page. Okay. Wow, a lot of space for question 8. Does that mean it needs a lot of work? Probably not. Let Pn be the proposition that... Okay, so it's induction. Which option represents a correct formulation of the assumption that pk is true for all values of k that's a positive integer in a proof using mathematical induction? So, this question essentially wants you to look at the inductive step. The inductive step is assume. Basically, it's just assume, and it kind of tells me in the question, that n equals k. If I assume that n equals k, it means everywhere I have the letter n, so here, 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 that needs to be replaced with the letter k. It's very simple. It's just a straight substitution. The r's will just stay as r, and they have to stay as r because r is not the letter n. I can go deeper into like the whole sigma notation and how you get to the answer, but that is the crux of it. K's replace the letter n's, the letter r's just stays letter r, and we are happy with that. So, if I have a look, in part A, they replaced both the n and they replaced the r's here. It cannot be A. In part B, well, this part is correct, right? All these parts are correct. They all should become k because there's an n at the top. So that part's correct. But if we look here again, I've got k instead of r, so it can't be b as well. Because again, they've replaced the letter r with k, and that's not how we do it. In part C, we have k in the right spot here. Wait, that's the wrong question. We have k in the right spot here. R's in the right spot, K's in the right spot, K's in the right spot. So C's perfect. It should be C. We'll just make sure there's nothing tricky going on with part D. In part D, they put R's here. I think that's the one that's maybe the easier one to spot. Can't be the case. So the answer is going to be part C for question 8. And this is really like some of the multiple choice questions in the specialist paper. You don't really need to work a solution. It's just testing, do you understand what the heck is going on? And if you understand what the heck is going on, this question can take you a very short period of time to answer, but it can be quite a confusing setup. So, we got slope fields. Okay, the slope field for the differential equation to y dx equals y minus x squared is shown. So we don't really, like the equation isn't that important because we have the slope field anyway. We don't need to make the slope field. We just got the slope field there. And if we had to make a slope field, it's like, I don't know if I've even seen a question like that in the QCAA paper, but that would be a tech active type question. But even then, I think that would be possibly a difficult one for them to ask in a way that's manageable within the time limits. So the solution to the curve of the differential equation that passes through the point 3 minus 5 also passes through which letter? Okay, so this question I just know because I've had so many students ask me about how to answer this question. Slope fields can kind of get people a little bit with like, how am I meant to project the points? Is it not going to be S? Like S is the really common answer and it's going to be incorrect. So with the slope fields, when we're trying to get a general vibe of the line, we can't really break the direction of the slope field too much. We have to infer a little bit, but we can't go crazy. And what I mean by that is I'm just going to zoom in on the slope field to kind of show you some different options. I'll zoom out slightly so we can see. If we go from 3 across here to S, do we see how this line here is basically going straight up and I'm going at an angle that is very different from that straight up line. So I can't really get from this dot to S very easily. I have to kind of go with the grain of the slope field. Also, I'm going to use green to do this color. I can't really get to point Q without going back against the grain of the slope field. So I can rule out S and I can rule out Q. It's just very difficult to get there without basically ignoring the lines on the screen. What each of these little lines mean, and I'll get rid of all this so we can kind of see what I'm saying. Each of these little lines mean the gradient at this point for your line should face that way. The gradient at this point should be this way. Gradient at this point should be this way. The gradient for something like over here, if I had a little dot, would be that way. So each of these little lines are kind of like a mini linear function showing a gradient. So I want to get all the way to point P. So I have to kind of go with the vibe a little bit. I'm quite steep at the beginning, right? I have to come across, and eventually I'm going to flatten out. But if I come up, I'm going up. It's pretty straight, but I'm also, you can see by, and I'm freehand drawing. I'm going to try again. I am freehand drawing here, right? But we're going with the grain. We are angling a little bit in that direction, okay? So I can kind of head a little bit in that direction. And as I kind of go across, you can see these lines are very straight here. They start to flatten out as we go vertically up the stem. So as you go up the stem, we're actually bending a little bit this way. And again, we don't need to go too deep because we're trying to pick which letter makes the most sense. I'm just trying to explain how we draw an approximation, and all this is an approximation. Very difficult to do this perfectly unless you're a computer. So if I go with the grain, kind of coming up, I'm kind of hitting this point here where I start to dip down. I start dipping down and I start bending back around, and that is how I get to point P as the most logical option for what my slope field looks like if I try to follow the grain. It is very difficult. So you can kind of do it the other way around. I can't get to S, we saw that at the beginning. Q is impossible because I have to go backwards. And getting to R is really, really hard because I have to essentially get from here across to there, and you can see how far steep I'm going by the time I get to this point. It's like a wave kind of pushing me up. You can almost think of it as like a current kind of pushing your line in a direction. It's very difficult. You have to go against the grain or against the current quite hard to get to R. So P, you can see, actually does kind of make a bit of sense the way it bends around. P is going to be the most logical option. And if you look somewhere like here, oh, that's an eraser. If you look somewhere like here, you can see I'm very close to kind of matching the general feeling of the curve. And that's all we're doing. We're approximating the best way possible. So my answer for this question is going to be P. And this is one I remember because it has caused so many students I've taught so many headaches with how the heck do we know it's P. Okay, final question. Question 10. Question 10. The 2016 Australian census recorded the number of bedrooms per... I'll zoom in a little bit. Number of bedrooms per household. The results are summarized in the histogram as shown. Based on this data, the mean number of bedrooms per household was calculated to be 3.5. So I know my mean is 3.5, and I'm looking at my frequency table. It's fine, right? You can see it's a little bit more skewed towards the... Like 3 and 4 are the main areas. So we're a little bit skewed towards the right. Just slightly skewed towards the right. It's a bit balanced out by the 2, but not that much. So 50 samples, which is a high number of samples. So with the high number of samples, anything above 30, we are going to get something that looks pretty close to an actual bell curve. So this number is really important, okay? Less than 30, we're not going to get a very good bell curve, but above 30, 50 is almost double, right? So we're going to get a pretty good looking bell curve, and by bell curve, I mean we should get a shape that looks something, well, that's a pretty messy drawing, but something like that. That's the idea, right? So you should get some kind of bell curve. Good sample size as well. The histogram that most likely represents the distribution of the sample mean is. So we should also recognize that the 3.5, that is the mean given to us in the question, that's this number here, that should be in the center of these as well. Okay, 3.5 should be in the middle because the sample mean should be the center of my distribution, right? This is going to be kind of X bar. Sometimes it can be U depending on what we're looking at, population, and how big the samples are. So have a look, okay? Have a look at all my options, and I can see that all of these represent pretty good bell curves, except for C. C is probably the worst looking bell curve, and I said it should be a good looking bell curve. So I can rule out C because it just doesn't represent a normal distribution. I have 50 samples. It should be looking like A, B, or D. All options are pretty good. Again, process of elimination is really good for the statistics-based questions. I'm going to zoom in slightly because we just really need our answers now. I said before that I know my mean needs to be 3.5. I've got a mean of 3.5 here. I've got a mean of 3.5 here. I do not in part B, so I can also rule out part B, and now I'm just looking at part A versus part D, and my head is in the way a little bit. I'm going to just hold it there so we can, oh my god, I can't talk, sorry. So I can scroll across a little bit and we can see the entire picture. So I said it's a little bit more skewed towards the right. You can see there's a lot more 4s than there are 2s. So we're just kind of looking at, okay, what's going to be the best case scenario, most likely to represent the information. If you look at the spread, so I said it should be a bit more right skewed, that makes me lean towards D. If you look at the spread of data as well, you can see in part D, it goes from basically 3.2 to 3.8. Okay, I'm going to let this go. Sorry, it's behind my head a little bit again. But what I mean by that, I'm going to get my highlighter out. Actually, I can use my second hand. There we go. And I can see here, it is, whoa. Oh, because I'm touching the iPad. Okay, hang on. Let me make this clear. 3.2. That's a line, but there we go, to 3.8. If we look at part A, I'm going from 2 all the way out to 5, and we look at our data, I guess it's possible. like I said, it's possible to get around that spread, but the spread of data is really, really big in Part A versus something like Part D, where it's a lot more compact, it's a lot closer to that 3.5. And again, we've kind of got this sort of frequency table here, where D is going to be the most logical answer based on the spread of data, it being a little bit more skewed towards the right. So my answer for question 10, the final question, is going to be D. Okay? So, I hope that, I'll scroll down a little bit so we can see, I hope that is helpful for everyone. That's the end of the multiple choice section. I did it in, about 30 minutes. So, like I said, you need to do it in kind of half the time, but I'm explaining each step and kind of doing the long way. If I was doing this, I would easily come within the 15 minutes. And that's really, if we're studying and we're doing multiple choice sections, which you need to practice, that's the idea, right? You want to be able to do this section in about 15 minutes. That's your sort of time goal for how you can get to your answer. And that includes interpreting and reading some pretty wordy problems. So for the quick skills, we need to be on our quick skill game. Fluency is the maths word, right? We need to be fluent with a lot of our maths processes so we can get to our answer relatively quickly. Okay, that is it for the end of the video. Again, if there's anything you guys want me to see, especially if you're not doing Queensland, if you're doing other curriculums, you want me to do a VCE paper or New South Wales HSC papers, WACE, whatever exam boards you're from, if you want me to do papers from them, I'm happy to as well. And I'll see you guys in the next video. Like I said, feel free to leave comments down below if you have any suggestions or anything like that. And I look forward to seeing you guys all in the next video. Goodbye, everyone.